On this episode of Startup the Science.
Hi, we are at Addionics. We are developing the next generation of batteries to produce high energy, high power batteries. We can reduce the charging time by 50% and improve the accessible capacity up to 200%. And this is without any negative effect on safety or the cost. The opposite, we can reduce the cost and make your batteries much safer. We are applicable to many applications. Right now we are working with the automotive, but it's not limited. It can be for any factory in the world. Our structures will be integrated in every factory in the world.
Hi, Moshiel. You're very welcome to Startup the Science. It's really great to have you with us. We've been trying to get Addionics on this podcast for a while. So I'd like to start by asking you to tell us a little bit about yourself and, of course, your company.
Sure. Thank you very much, Antonia. Super glad to be here. My name is Moshiel. I'm the CEO and co-founder of Addionics. I have a PhD in materials science, focused on batteries. And my background is also material engineering from Israel. I'm Israeli. And I moved to London for my PhD. Back then, it was a bit unknown how the battery domain is going to be in the future. I came from the semiconductor industry, where it was more established, attracted more talent, and it was a bit a risk. People ask me why you want to go to a battery, and it was just the beginning of Tesla. And of course, today everyone understands the benefits and how this market is crowded and exciting. And during my PhD at Imperial College London, when we researched a phenomena that caused batteries to explode, and I researched that phenomena for more than 4 years. It was the cause of the explosion of Samsung Note 7. If you remember, when we went to a plane, everyone told us, oh, if you have Samsung Note 7, please come to the stewards and give it and put it in a special box. So we were the first researchers, myself and my PhD supervisor, to look at this phenomena at real time. And we took it for very fancy equipment, instruments, synchrotron, lots of those funky words. And we tried to look on the phenomena in real time. And that was the first. And we published in the best journals like papers and our findings and results. And after 4 years of research in this topic, yes, poor guy, this is what I did for 4 years to look on the phenomena that caused the explosion. I realized that now I know how to control it. Now I can maybe take it and to use it to our benefits, to take a byproduct, negative, to something positive that can actually improve and make something good to the world. And I came to my PhD supervisor and told them about the idea. Usually they're, academics. I used to admire them. I still admiring them. Try to find why things are not going to work. This is what people telling us in academia, to say first to find why it's not going to work. And first time in all the history, and I worked with them for 4 years, that they told me, it may work. So for me, this gave me appetite for starting the company. And it started as a joke. I told them, I'm going to build a company and you're going to work for this company. They started to laugh. And today, all of us actually running this ship that calls Addionics.
So your journey started in academia about 7-8 years ago, I guess, right? That's when phones were exploding, if I remember correctly.
Correct.
Approximately then. And I love hearing these stories where it starts as a research project, but then it turns into a company and a quite successful one. And yes, it is also quite common that we hear that in academia, the spirit is more to figure out why things don't work and how to say no is how to say yes. So when you decided to make this transition and to take the idea out of a purely academic setup and turn it into a company, what was your main motivation? Why did you want to do that? Was it to become a very successful entrepreneur and make a lot of money, or are you more focusing on the impact your technology could have on the world and the benefits different industries could get from it?
Sure. So yeah, we got the inspiration during my studies, but it was just an inspiration, of course, to make it happen and to make things like looks real. Something that you need to invest lots of resources, effort, energy. So difficult to do it while you are doing your research part of your PhD. So I knew that if we want to take this idea forward, and it was a bit too difficult just to stand behind and to say, okay, we got inspired of something like that can change the world. We cannot stand behind. We need to do something. And all of us are academics. So usually just to make money and to be successful is not our first priority. We went to academia to research, to have like fundamental findings, understanding, to better know the physics, the chemistry, the fundamental phenomena. And for me, it was quite clear that if I want to make a company out of it, and was clear for me, I need to do it full time. And not only me, also my partners. You know, there is no half pregnancy. Either you do something and you are on it with all the energy. And for a startup, the risks are huge. So if you want to de-risk and to have more chances for your company to be successful, so we've decided to step out, and I managed to convince, it was very difficult to convince my PhD supervisor to step out their very promising academic career. But I promised them, I would say, a better and greener future with a greater impact. And I think now these days, everyone is pleased about the opportunity. So it's super exciting for all of us.
That's nice. So tell me a little bit more about your co-founder. So you convinced your academic team to come on board and join on this pretty risky startup journey. Who's in your founding team?
So the two co-founders are Dr. Vladimir Yufit and Dr. Farid Tariq. When he asked Vlad where he's coming from, he would say from the former Soviet Union. And then he moved to Israel. He did all his degrees in Israel. Later, he moved to London, to Imperial College London, where he used to be an assistant professor. And funny thing that Vlad wrote a proposal for the position that I got at Imperial. So I won the proposal that Vlad advertised. And for me, he was one of the best electrochemists that I ever dealt in the world. And Farid is from London, originally from Pakistan. So you can see that we are a super diverse team or super diverse funding team. And he is one of the best people. He's a magician of modeling, simulation, image processing for battery or energy devices. He also used to work at Shell, Alstom to develop these methodologies for the industry. And so I told you about seeing in real time what is happening inside the battery. So Farid is able to take those experiments and to turn them into numbers, details, and to run simulation that based on real numbers, so we can close the loop and understand much better how simulation can help us to save time, to simulate the real world. So Farid is a magician. Vlad is, I would say, this professor that knows everything about batteries. And that was the delivery boy that tried to get things done, to find the right partners, the right funds to make this company successful. And at the beginning, it was lots of luck, beginner's luck. It was a competition at Imperial. And I heard about the competition and I told to Vlad and Farid, I'm going to put you on the slide. Just, to get their permission that they will not be surprised someone will tell them that they're on slide. And I went to this competition and I presented the concept, what we're trying to do, how to take the phenomena and to turn it into a positive aspect. And in the panel was few people, some of them professor from chemistry background, entrepreneurs, business people, and the chemistry professor, Professor Richard Templer, because it was obvious for him. He actually are familiar with the phenomena. So why not to take it to the real world? But the business people realize that there is a good opportunity, but they ask, what make me as a CEO of a company just finish my PhD? So how come you can be a successful CEO And then I started to use the tools that I have from Israel. We're a startup nation. Everyone went to the army. I was a sergeant in operation, turning courses. So for me, I was dealt with situation which is much more stressful than start a company. I was in battlefield. So what is for me to manage few people in a company? A piece of cake for me.
Was that your answer then? Is that what you said?
Yeah, that's my answer. And they started in Israel, everyone was laughing and make fun of me. Everyone is doing that, so don't tell us the story. But for me, it was actually that's the truth as well. So it's not something fake. I served the army. I was a sergeant and was in very intense situation and able to conduct and to lead very successfully. And I told them I have these managing skills. So the business people convinced, they wrote a check of 60K euros. And then we started. From then, everything was so difficult. And we understand that it's not going to be easy as it was in the first meeting. But I came back to my supervisor and told them, guys, we want a 60K. We need to open a bank account. We need to file a company.
So at this point, nothing was on paper, right? There was no.
Settled. No, nothing. Just an idea.
Did you have the name? Was it called Addionics at that point, or was it just an idea with no name?
No, when we actually started to, we needed to file the company in the company house in the UK, and we needed to come with a name. So Vlad, as I told you, that is the super smart person. He came with a name. He actually think about the inspiration, what we found, what we can develop, what is the technology. And this is abbreviation of the technology. So Addionics, it's additive deposition from ionic solution, which we are building 3D metals from aqua solution. It looks like, the Terminator, a magic, but we make it for real. And we're taking liquid. There are lots of ions of metals inside the liquid, and we know how to control to make them connect together and to create a 3D structure.
Okay, so let's go a little bit deeper into the technology since you've already started talking about it. What we find interesting, because as you mentioned earlier, the battery startup space is crowded. There are quite a few startups in the world developing battery technologies. And one of the things we found very exciting about your technology is that it seems to approach things from a different perspective. There is not as much focus on the chemistry as there is on the physics of a battery. And I wonder if you can tell us a little bit more about that and explain it, maybe so that everyone can understand what that means. What does it mean that you're not focusing, I don't know if you're not focusing on the chemistry at all, but that you're focusing on the chemistry less and the physics of the battery is at the forefront of what you're doing? What does that mean?
Sure. So actually, it's not only startups. All the world, like research center, universities, giant companies, startups as well. Everyone is seeking for this new battery that's going to help everyone in his daily life. It comes from our smartphone, mobile devices, and of course, electric vehicles, as the world is in this electrification revolution. And in the last, I would say, 20 years, 15 years, most of the focus was on the chemistry of the battery cell, if it's on the anode, on the cathode, the electrolyte. This is the energy, the active material in your device. So everyone was trying to improve the active material. This is what brings you energy. And the last 5 years, there is more focus on engineering, but mostly in the manufacturing process. There are lots of trends and lots of also buzzwords. If it's going to be dry coating, we are moving to new terafactories to make it at scale, to reduce the price. The cost is the main issue for the batteries. At the end, battery is a commodity. If we want to move to electric vehicles or other devices that should be electric, we need to make it in a reasonable price. But most of the focus, especially for the big manufacturers, was on the manufacturing process. And they kept on the production of the cell, of the structure, really, I would say, similar to what exists in the last 30 years. So all the lithium-ion batteries that exist today, their structure, like 90%, didn't change. We have the same architecture that invented back then in the 90s. Only today, Tesla are saying or showing few steps that they're going to focus also on the cell design. But even then, until now, they use the same design that invented back then in the 90s. So even Tesla, thinking about that, but a bit late. When we started, we were like one of the pioneers that realized that this is the focus. Again, there are few companies that did it before us. So the architecture is important. And we believe that is the key to improve because there are lots of improvement on the chemistry. We managed to get into some saturation, a steady state when we don't see a step change in the performance. And there is a clear need for the physics, for the architecture to be improved.
So if you are focusing on the architecture, what are the materials though that you are using?
So maybe to give you a better definition about what we do, let's go back a little bit about what is a battery cell, what a cell consists of. So in a battery, you have a two electrode separator and electrolyte. This is the basic components that you have in a battery. Each electrode consists of two components. The active material, the anodic material or the cathodic material, this is the active material, and the current collector. The current collector is a 2D metal foil, similar to the foil that you have in your kitchen. And this foil is flat, completely dense, and 99% of the batteries in the world are based on this component. And how the company evolved at Addionics, we first found technology, process to produce high quality, scalable, cost-effective metals at high resolution. So first we developed copper, and then we developed other type of metals. And we ask ourselves, and this was the beginning of the early days of the company, when we understand that technology is not enough, we need to come with a product. And as a battery scientist, that for us, batteries, we did for a living. That was our day-to-day activities. We understand that this component, no one is looking on the metal in the battery. Everyone is taking that for granted. And we went to find like papers, research, and we asked ourselves, and we found that the many studies that showing the advantage of moving from 2D flat foil to a porous 3D metal structure. There are many benefits, but this invention remain at the side. It's not a mainstream. You don't see that. And the reason for that, because all the options to make those 3D structures were very expensive and not battery graded and not suitable for scale and for mass production. As you mentioned before, batteries, commodities, we need to make them at least with the same cost that it exists today. But the idea is not only to improve them, but also to reduce the cost. So if you are going to make batteries more expensive, it's not going to be relevant and attractive for the market. So thanks to our invention, our technology, we've managed to build an enabler to make those structures in a cost-effective and suitable for batteries to improve their performance. So that was attractive for us, and we found, okay, that's the market that we're going to tackle first.
So cost effective is one element of it, and you mentioned that. Obviously, the other very important part is to make sure that they're efficient and they store energy properly and they deliver it when they have to deliver it. The other part that I'm thinking is also quite relevant is how safe these batteries are, because we started this conversation by talking about phones exploding. It's much worse if the batteries of electric vehicles start exploding. So can you tell me a little bit about the safety aspect of your product?
Yeah, actually, we just published an article that emphasized the advantages of our safety using the 3D electrode. We call it smart electrodes because we know how to design. We are running simulation, modeling, understanding how it's going to behave during the manufacturing process and during operation of the battery. Taking all this information, doing like reverse engineering, and going back to manufacture and to assemble this type of batteries. So when we're talking about safety, we need to understand what are the advantage of 3D electrodes. So we don't have like a 2D multi-layer structure. So our structure is hybrid. The active material is integrated inside the metal framework. So we have a structure that helps us to increase the surface area to have much better contact between the active material to the metal framework. By doing that, we increase the adhesion, the contact between the materials. We are more suitable for aggressive conditions. One of the main reasons for degradation in the battery is the elimination, separation. So in terms of mechanical properties, it's much more. And in our test, the first test that we did, it was 14 times more stronger than conventional structure. So it's 14 times you need to apply greater force in order to differentiate, to separate the layers. So this is one reason. And when, of course, battery is separated, there is more chances for degradation, failure, and safety issues. Another reason is heat dissipation. When you have a 2D metal, let's look on the anode side. The anode, you have metal foil, copper foil, which is very good conductor. Usually in lithium-ion batteries, you have graphite material. Graphite compared to copper is almost insulator, it's not conductor or good conductor as copper. So if the heat want to dissipate in the interface when you are generating lots of heat, the heat will actually move only towards the copper. So you will look on the graphite and will see a block, insulated. It's not going through that. And if you have a 3D metal framework, the heat will dissipate it in 3 dimensions. It's not limited only to 1 dimension. Moreover, we can keep the temperature homogeneous, so the distribution is even along all the cells. And those hotspots that created in the interface or the areas that the heat is generated and not dissipated cause to some safety issues, materials, decomposition, and things that cause a problem. And if I'm going back to the Samsung Note 7 explosion, one of the main reasons for the explosion are dendrites. Dendrites are metal spikes, looks like the Christmas tree, and those spikes can penetrate the membrane. And when you have a contact between the two electrodes, anode and cathode, there is a short. Then thermal runaway, fire, and explosion, especially when you have liquid electrolyte, which is very flammable. And those spikes are growing. And what we saw with our structure, they are more suitable for preventing and mitigating with the growth of the dendrite. So this is another aspect. There are a few other aspects which you are welcome to visit our blog and to find more about our safety.
So in a nutshell, your batteries are leading to significantly improved thermal uniformity, way better mechanical stability from what I gather, and they're just overall better, safer, and it could be applied in a whole range of products. So if we go into that a bit, you already mentioned Tesla, and I wonder, maybe you can tell me if they are a competitor or if they're a future customer, or how do we view Tesla? But what are the applications that you guys are focusing on most at the moment? Because from what I understand, your batteries could be used in all sorts of applications, from electric vehicles to consumer electronics, phones, laptops, wearables. Are you focusing on only some of these products? Or are you trying to tackle them all at the same time? Or how are you going about it?
Yeah, it's a great question. That's the $1 million question. What we should focus on, what verticals. So right now we are already working with automotive companies and micromobility companies, with material companies to develop the next generation of batteries with different chemistries. All the idea is to show that we are not limited to one chemistry and the potential is huge. The market is huge. We are not market limited and not chemistry or technology limited. And we're chasing after like a huge opportunity. So we are working with automotive companies, and now we'll start working also with consumer electronic companies, start to understand the value, to build like samples that will be suitable for this market. Usually the automotive market scales are long, taking time, and we want to gain more knowledge, experience, and to transfer this know-how into the automotive domain. We need also to get lots of know-how and knowledge on the manufacturing, how to do it at scale. Right now, we're doing that in a small volume. We want to increase the production volume, learning how to do it at the speed, at cost, yield that is necessary also for the to big volume applications. And then we want to have the ability to choose what is the most suitable for us as the company, and then to grow and to serve more industries, as more the merrier.
And as you're trying to access the automotive market, what are the challenges you're facing? I can imagine from what we know about this market that it can be quite slow. I mean, these are very large companies that you have to partner with that may have their own R&D, probably have their own R&D developing technologies in the space. As a startup, when you're trying to turn them into customers or partners, what challenges are you facing?
So the challenges are evolving and changing with time, and also the automotive industry getting mature with the understanding about their part in this electrification revolution. If 3 years ago, when we started the company, we started to talk and said, "Oh, don't talk with us, talk with the battery manufacturers. They developing for us cells." Now they're starting to developing battery cells by themselves. For them, it was a black box. The automotive industry, they look on cells, battery cell, as a black box. They didn't know what is inside, and they lost their ability to be the owner, because the cell is the king. The cell dictates the performance of the vehicle, and also the cost is derived from the cell. So now they realize that. So the beginning, the challenge is to tell them, guys, you are going to miss the train. You need to be on top of that. This is the key component. You need to understand that without focus on the cell, without understanding or knowing what is happening inside, you're going to lose it. And we say that from the beginning. And now, thankfully and good for them that they're starting to realize that.
So before I ask you to share with us your asks for the Enam Network and listeners of the podcast, and what help you might need and what you're looking for, I have one final question that is more just curiosity. When do you predict that we'll see electric cars only on the streets instead of the very polluting cars we see at the moment?
Yeah, so it will be a transition. We can see that today more and more models from the lead OEMs are in the streets. When all this transition is going to over, I think it will be sooner than all the expectations and the vision of the companies. And it should be also together with, as you mentioned before, with government. So specific date is difficult to predict, but sooner than we think.
So like 2030 or sooner than 2030.
Still, we'll have few, vehicles which are not be electric, and it will be a transition. So in the next 10 years, we'll see hybrid and other type of vehicles. But the goal is to move to full electric vehicles for sure.
So as we're coming close to the end of our conversation today, I'd like to ask you to ask us how we might be able to support you. So are you looking for investors, partners, customers, or how might the listeners of this podcast be able to help you guys out?
So first, we'd like to thank you for all your support and assisting us in the past and today. I will recommend the other startups to use your network and support. You introduce us to investors, to partners, potential partners. We had amazing insight and discussion with the intros that you suggested us. So thank you very much for that. And I think as every startup, we would like to reduce the risk of the startups. So any assistance that will de-risk the many risks that you have already, it's blessing. So thank you very much, and we'll appreciate this type of further assistance.
And we'll make sure to put all of your contact information in the description of the podcast. So if anyone wants to reach out for further questions or conversations, or if they have questions about your batteries, they can do so. And if any startups are listening and they want to join our network, they're also welcome to do that. Thank you very much for being with us today, Moshiel.
Thank you very much.
Thanks for listening to Startup the Science. If you'd like to learn more about our podcast, head to www.enum.berlin/startupthescience. You can also follow us on YouTube, LinkedIn, Twitter, and Instagram. If you'd like to leave us a message or ask us or our guests any questions, send us a DM or leave us a message on our website. We would love to hear from you. Stay tuned for our next episode. Coming soon.